Okay, what we have here is a three-phase induction motor, 6 lead, so we're going to be connecting this up in two different configurations. The very first configuration is going to be a Y. As you'll see here, I'm connecting it through the amp meter to demonstrate the difference between a Y and delta connection. When I hook it up in a Y, you're going to notice that we're going to be pulling considerably less amps than the delta. It's the way the windings are configured and the way the voltage is spread across both windings when you connect it in a Y configuration. Right now I've got the leads coming out of the amp meter in series with the three-phase A, B, and C coming in. I got it connected to 1, 2, and 3 on the motor terminal leads themselves. And then on the opposite side, I'm jumpering 4, 5, and 6 together, tying them together in a Y. A lot of times this type of configuration is done for motor startup. If you notice on the amp meter, it bounced way up because we're pulling a considerable inrush current when we first start up a motor. In this configuration, we call it Y delta starting or star delta. We're pulling 0.7 amps with the Y configuration. To reverse the motor, I simply interchange the two leads, which is typically done on the A and C phases. Next, I'm going to be hooking this up in a delta. So I unplug my leads here. I'm going to do the same thing. I'm going to bring my A, B, and C phases through the amp meter and connect to the terminal leads on the motor. Same thing again, 1, 2, and 3 to my line side. But this time I'm going to go 4 to 2, 5 to 3, and 6 to 1. Now I have to jump up the amp meters because we're going to be pulling considerably more current. As you can hear, it's got a lot more power and torque on startup because I'm giving the windings full voltage and going across the windings with full 208. It's pulling 4 amps, almost a little over double what the other star was pulling. Okay, what we have here, this is a single phase motor. This is considerably different to a 3-phase motor. Just like it sounds, it only needs 1 phase to be able to power it up. But the problem with it is it doesn't have a naturally rotating magnetic field. So this time we need 2 different windings, one being the run and one being the start. As you can see here, I've connected my hot and paralleled both to the run and the start winding. The run winding is on top and the start winding is below. I jumper across the centrifugal switch and connect my neutral and parallel that in series with the centrifugal switch. Turning on the motor, as you can tell, it's jump started with the start winding that gets it going. And to reverse it, this time I simply interchange the leads on the start winding and thereby reversing the polarity. And there you have it.